Okay, let's start review for exam 1. The total 32 questions, so I won't be able to finish in one video. I'm going to split into a couple of videos. All right, let's see the first kind of questions. Express each interval in set builder notation and graph it on the number line. So we need to do two things. So first, we want to write in set notation. So let's say A. A means the value of x. Let's use variable x. X is a variable representing all the numbers in between -1 and 1, but not including -1, not including 1. So we use this less than sign. So this is a set builder notation. So the value of x, so in between -1 and 1, not including -1 and 1. And to draw a number line, to draw this solution set on number line, so draw a line. Then we mark an arrow. So see this, basically this is like an x-axis, real number line. So then we mark a 0 somewhere for our convenience, right? For this one, I can draw 0 in the middle because I only have to mark -1 and 1. So let's see, -1 is here. And 1 is somewhere here. So all the values in between -1 and 1, but not including -1, not including 1. So I indicate with an open circle. Then I draw this line saying, okay. So that's my graph. A graph is from -1 up to 1. So we always look from left to right, from a smaller number to right number. If we remember, on the very left end is -infinity. On the right end is positive infinity. Infinity is just an idea. Okay, it just means these numbers to the right grows bigger and bigger. To the left, it becomes smaller and smaller. So that's one. So let's say B. Set notation, because it's bracket, so now we have equal sign involved. So start from -4, less than or equal to. So I won't be able to write the usual way, less than equal to, so I'm writing this way. Less than or equal to, and we use the variable x. In the interval notation, we don't have x, but in the set builder notation, we have variable x up here. Less than or equal to 9. Okay. So bracket means less than or equal to. So -4 and 9 is in the set. To graph it, let me use a red color to graph this one. So -4, you know what? Okay, let me change it. You know what? Let me just redraw, okay? It's difficult to, let me just redraw another one. Let's see, this is our x-axis. And because we need a number 9, we needed to draw number 9 and number -4. So maybe we draw 9 here, right? Then let's see, 0 is somewhere here. -4 is about 4, half of 9. So a little less than half. So -4 might be here. So I only have to draw these three numbers, -4, 9, and 0. We always have to draw the origin 0. Okay, so including -4, I'm going to mark with a solid dot. So basically filled in circle, solid. Including 9 also, because I have a less than or equal sign. So equal sign is there too. I draw solid dot. Then I connect those 2 points. So all those are in the set. Those are in the set. Now let's see C. From -5 up to infinity. Let's do set notation first. Including -5, it's also less than or equal to. We use variable x, then less than infinity. Infinity is an idea, so we never use a bracket for it. We always just less than or close parentheses, right? So how do we graph this one? Let's draw another one. This is our x-axis, so we need to draw. We only have to draw two numbers here. So we need the origin, always need the origin, then -5. So -5 is in the set. Again, solid dot, because it's greater than or equal to. Then from this -5 up to positive infinity. So we indicate with an arrow to indicate this goes up to infinity. That's the graph. That's a D. D, negative infinity. So I'm going to x less than negative. So I'm going to write infinity sign. Negative infinity. So we always start from the smaller number to big number. So from negative infinity up to -4, that means less than -4, right? We indicate it with greater than negative infinity. So this is set builder notation. No equal sign here. No equal sign, so when I draw open circles, right? I only need 0 and -4. So I draw 0 somewhere. I draw -4 somewhere. Then all the numbers are smaller than -4, not including -4. So I draw open circle. Less than, I go to the left. On the left-hand side, negative infinity. That's the graph. Excuse me. Okay, that's for this question. Let me clear this. Let's see 2, absolute values. Absolute values. So the first one, of course, absolute value of -6 is a 6. Okay, the meaning of absolute value only considers the distance from the origin. Right? What's let me just illustrate the idea of absolute values. Let's see, 0 is here. -6 is here. Absolute value of -6 means we only care about the distance, how far this number from the origin which is 0 here, or which is 6, the distance. Okay. But let's see this B. B, the negative sign is outside absolute value. So inside absolute value is a positive number. If it's a positive number, absolute value is still positive number. The negative sign is outside. It's outside the absolute value. So we still get a -3.5. For C, the negative sign is outside. The negative sign is outside the absolute value sign. So we still get negative. But the absolute value of -8, that's +8. So we get -8. D, we have inside, we have half -1. Well, half -1 is -1/2. But the absolute value of -1/2 is just +1/2. So get a +1/2. Okay, so that's absolute value. Now let's see 3. Complete the table of values for the equation y equals to x² + 1 and graph. Select integers from -3 to 3. So let me erase the other things. So let's make a table. So let's make a table. So pick some values from -3 to 3. So let's pick 7 values. So 1, 2, 3, 4, 5, 6. Then let's do one more. And what we need x value we need a y value, then we have a point. Okay. So, okay, so let me type. So on this column, I'm gonna write x value, this column, y value, and lastly, that's the point, x comma y. Because we need a graph with points, right? So we pick from -3 to 3. So we pick -3, -2, -1, 0, 1, 2, 3. Right, pick those values. Then we plug into this equation y equals to x squared plus 1 to get a y value. Well, when x equals to -3, -3 squared is 9. 9 plus 1 get a 10. When x equals to -2, -2 squared is 4. 4 plus 1 is 5. -1 squared is 1. 1 plus 1 we get 2. 0 squared is 0. 0 plus 1 we get a 1. 1 we get 2. 2 we get 5. 3 we get 10. Okay, so we get those points. We get -3, 10. Okay. We get -2, 5. We get -1, 2. Get 0, 1. Get a 1, 2, 2, and 5. And lastly, we have this 3 and 10. So let's graph those points on the plane. So let's do the plane here. Because we have to go up to 10, right? We need numbers. So x value we only need from -3 to 3. So maybe we do 1, 2, 3. Right? So 1, 2, 3. And then -1, -2, and -3. And y value, we need 1 up to 10. So maybe let's say 10 is here. So you know what? I've made a mistake. I should draw the x-axis much lower, right? But I have done this already. So let's see, because we don't need negative y values. So I don't have to draw x value in the middle of it. I could make this x-axis much lower. Okay, anyway, let's work with this. So 5. Then we need a 2, right? So cut this into half. So let's see, this is a 2. Then we need a 1. So 1, let's say this is a 1. All right. Okay, we have -3 and 10, -3 and 10 somewhere here. We have -2, 5, -2, 5 somewhere here. We have -1, comma 2, -1, comma 2 somewhere here. We have 0, comma 1, we have this point. Then we have 1, comma 2. We have 2, comma 5, symmetric, quadratic equation, symmetric. We have 3 and 10. We see an upward parabola. So now let's graph. We graph like a roundish. It's not, oops, I'm sorry. Roundish, not a straight line. All right. Quadratic. Oops, oops, oops. Then we indicate it with an arrow, which means it keeps going. That's it. That's the graph of this equation y equals to x squared plus 1. All right, so you do the same thing for 4 and 5. I'm not going to do all of them. So just give you some hints. So this linear equation is much easier, right? You evaluate, you do the same thing as me. You give x value -3 up to 3. Then you find the corresponding y value by this equation. Then you find these points, then you graph, all right? But this is a straight line. Then absolute value function is a V shape, right? You get a V shape. So this one, you get a straight line. And 5, you get a V shape of this graph. Right. Let's erase this. Let's keep going. Let's see 6. So we want to solve this linear equations. Linear means the variable, the exponent of the variable is just 1. Right? You say x raised by 1, y. Just 1. This should be easy, right? But let me do A. So I do A and maybe D. Okay, you do the rest. So A, I have AX. Now I distribute -2 for x and for 5. So I get -2x, -10. Then equals to I distribute -4. So I get -4x. -4 times -1 becomes +4. And then +6. Then I combine like terms on both sides on the same side. AX minus 2x is 6x. Then -10 equals to -4x plus 10, right? 4 plus 6 plus 10. Now I want to combine like terms from a different side. How do I do that? I got to move around. So I move -4x to from the right hand side to left hand side. I get 6x plus 4x. Right? When I move one atom from one side to the other side, I change its sign. Negative becomes positive, positive becomes negative. Then I move -10 from the left hand side to the right hand side. So I have 10 plus 10. So I moved the -10 to the right hand side, become +10. I have moved the -4x from the right hand side to the left hand side, become positive. Now I can combine them. Once they're on the same, once they're like terms on the same side of the equation, I can combine them. 6x plus 4x, that's 10x. 10 plus 10, that's 20. I divide 10 on both sides, and I get x equals to 2. Because 20 divided by 10 equals to 2. So the solution for A is 2. Now let's do D. D, I have denominators. So I want to get rid of these denominators. How do I get rid of this? I want to multiply every term by the least common denominator, which is 12 in this case. So basically, I multiply 12 on the left-hand side. I multiply 12 on the right-hand side. Because I have an equation, right? I can multiply the same number, I can divide the same number, add the same number, or subtract the same number on both sides simultaneously. So 12 multiplied by this fraction, I think 12, because 12 is a numerator. 12 divides by 3, so I get 4. So that becomes 4 times x plus 4. Or 2 times 12, that becomes 24. Right? 12 divided by 4, that becomes 3. So this term becomes 3 times 2x minus 1. When I multiply by more than 2 terms, I always give a parenthesis. So this becomes 4 after I multiply by the least common multiple of 12. It becomes 4 times x plus 4 minus 24 equals to 3 times 2x minus 1. Okay, make sure you understand this step. Basically, I enlarged both sides of the equation 12 times bigger. That's what I did. Because it's an equation, we can do this. Okay, now the rest is just, simplifying, distribute and simplify. So I get 4x, 4 times 4, 16, minus 24, equals to 3 times 2x, I get 6x, minus 3. Now combine like terms. So 4x, 16 minus 24 is minus 8, equals to 6x minus 3. Then move around, move the like terms to be on the same hand side. So I get negative a minus plus 3 equals to 6x minus 4x, right? So what I did is I moved 4x from the left-hand side to the right-hand side. It becomes negative. I have moved the negative 3 from the right-hand side to the left-hand side, become positive. Now I can combine like terms. So negative a plus 3, that's negative 5. 6x minus 4x, that's 2x. I divided by 2 on both sides. Divided by 2 on both sides, so x equals to negative 5 divided by 2. Okay, in college, we like to leave the answer as in a fraction form. So the solution for D is negative 5 over 2, or negative 2.5 if you would like decimals. Okay, so I'm not going to do B and C. B is very similar to D. C is similar to A. Okay, so let me finish this. Let me take a little break. So I'll keep going for the rest of the review.